Evening, ladies and gentlemen. Thank you very much for giving me voice. Today, I will talk about different hydrogen energy forms of production, based on the recent review published in LSC Advances, and they titled the current status hydrogen energy on an overview published in cooperation of Kyoto University and the and and the and Natsuki University and Wien University from Vietnam under leadership uh, of Wien University Huang Le, doctor, and why it's made because achievements and data of hydrogen production real way is especially important and especially rapidly changing and with lots of outcomes. Therefore, reviewing of this needs to be continuous and focusing on different areas and indicate gaps what there wasn't made. The there is the researcher they show problems of hydrogen due to complex geographical areas or harsh climate, the storage, the techniques, energy efficiency, and manufacturing cost, and future for societal problems, and all these changes show this really profound evolution development process of human society. It has been assessed the same significance as previous industrial revolution. Over the past 10 years was been noticeable after Paris Agreement there was seeking the method for omission or overcoming the climate change and greenhouse effect and depletion and plastic contamination of oceans and environment, and these are topics that needs to made. The different energy sources include sun, wind, ocean waves, and hydrogen and others have emerged as the most surprisingly. And, and in the future, some other methods, and we need to make some more containing fossil fuels or more uh, more initial phase, initial and raw sources are solar and wind that are regarded to use and tied to be renewable energy, but we forget that often the building of such power plants consumes many fossil fuel origin material nowadays. Therefore, the, the maintaining of these devices would be troublesome because steel producing needed. So we need to transform them into the form that can be produced from renewable sources and we all ways, especially ways that we already generated to reduce our landfills and contamination. And clearly that majority of hydrogen, 48%, comes uh, from natural gas, 30%, 18% is produced for coal, and 30 for oil still. The electricity of water is used to 40%. And this is still changing and was 3%, 2% in 2015. So increase of 2% is very little and too little to make change. So there is the population growing to 2050, and in case would reach by 2150 12 billions, which is limiting for Earth. So we need to stop. The growing population needs growing demand of oil and natural gases, too high to overcome demands. The oil will be over in 2040, 50 for all years was simply more uh, more faster than in other regions. And by 2100, we will lose gases. So we need to change this transformation. And this is made the three factors that need to overcome. World of the population needs to stop growing so fast. We need to replace actual consumption of natural gas, coal, and which was from 20th century, and they replace with more renewable process. The hydrogen production efficiency is for steam reforming is 73%. Only from these methods of renewable percent is dark fermentation is given in case even 70% and 80% by electrolysis. The case is that we had it's much far efficient than in this biophotolysis. Biophotolysis is splitting due to algas. For biophotolysis algas, reduction of water. Our electrolysis is due to current, which needs to come from the solar and wind. There is also very low thermolysis by using only heat, for example, from nuclear plant, and biomass pyrolysis is only 40% efficiency. So still, according to this data, I think that dark fermentation efficiency was for modified bacteria, where it contains efficiency quite high, because very still lower efficiency production is in case of dark fermentation, or if want the graph is different. Here is still not considered like dark fermentation, photofermentation. So these data are not very precise here in this work of Professor Natsuki from Kyoto University and and Fong Ang Le from Wien University. So these are the trouble here. How to change this. And fossil fuel contain oils, which is gasification partial oxidation, while renewable ways is direct water splitting electrolysis called thermal solar. And these can be used as industry engines to the manufacturing process and power generation and fuel cell per demand. This is the how to change what the relationship we need to overcome. We need to industry for power generation, manufacturing process. We need fuel cell. We need transfer and fuel cell engines. There are some nuclear energy, but still far away. And here we have another technique, which is methane pyrolysis. Methane pyrolysis is natural methane for solid carbon. Other is for the water electrolysis, which is renewable if contain power from water or solar. It is also improved by Netherlands and Japan due to high wind problems in high wind conditions, which are required for efficient way. We have methane processes, we have gasification, which coal and air, but produce a lot of toxic more than metapyrolysis, and we have a reforming process. And this is methane steam reformer, shift conversion. And this is hydrogen production methods and fossil fuels. Water splitting, we have several hydrogen production methods, and we have several fossil fuels and renewable sources. So we have renewable sources for water splitting and biomedicinal source. They don't mention ammonia splitting and other compounds which can be split, which is somehow error because not full data. In case of dark biological problem, what is only dark fermentation and biophotolysis. They don't put an microbial electrolysis cell or photofermentation, and this is quite a big problem because it's not very structured, as not common. So we have also fossil fuels, which are chemical hydrocarbon pyrolysis. There are few methods of hydrogen production. The water steam reformer is still used mostly and produces and requires fossil fuels and requires some carbon. The biophotolysis has other significance that producing by what biophotolysis? Producing by algae, which are suitable for fuel waste, are for fuel oils as butanol or FAME, fatty ethyl esters and ethyl esters, and can be made by carbon dioxide capture. This is the case that carbon dioxide capture can be also obtained by algae. So production and cultivation use algae, and this can capture. The rest can be also by after fermentation this algae to produce polymers, so it's much simpler. Here is shown how is fuel cell electric vehicles. And methane, carbon dioxide, and nitrogen. And purification, water gas reformer. The nature creates oxygen as partial oxidation reactor, catalytic partial oxidation reactor, are other compounds. So this is the for partial emission. And natural gas and steam gives so combustion zone and thermal zone was natural gas and steam, smoking, and these give to signals. The fourth is pyrolysis. We have steam, gasification, shift, and to produce hydrogen, case from coal. But capture, we need to capture carbon dioxide capture to make. This is a big trouble in case of pyrolysis because still generates much carbon dioxide. And but in case of pyrolysis and gasification, we already have reactors already produced and designed. For dark fermentation and fermentation for techniques, we need to start to design the optimal scale reaction. So this is the trouble. In case of weight of spirit spinning, we also don't have design proper design. So this is the challenges to make. There are also electrolyzers which can be used for polymer, conjugated polymer, or from metal oxide, from and silica. Silica mostly preferred now because seems to be friendly besides powder for which can maybe cause silicolysis, where conjugated polymers are not made nowadays to fuel efficiency using renewable green chemistry method. The metal oxide is due to production. Often, mining is difficult, makes environmentally more devastation. So we need to for metals are fine, but they should be for waste material to be produced. So this is fine. This is the conjugated polymers needs to bring the band gap. So they needs to be between 1 and 3 electron volts, which is suitable for many materials. The other is hydrogen techniques and can be ammonia or hydrate. Here are not less has ammonia, however, is very fine. While physical based methods like compressed gas and liquid hydrogen requires much energy, so it's not very suitable because still generating materials, and we need methods which hydrogen storage would be energy suitable. There is however Porsche method which can be reversed for ammonia. They say here, not initially. So this is the also very good idea. We have some generation, synthesis, and use. So this synthesis, this transportation would be another trouble, how to transport. So maybe we need to some few power plants, like in ideas of Edison, not by Tesla power plants. So many power plants maybe would be more suitable for this case, and more workplaces. So the growing society would have some some job. So this is the all cases. And unfortunately, my country is very low. In case of renewable case, also only 0.2%, while is much less than France 0.7, 0.5, or Germany. So we have very low in case of European Union in Poland. So this is the big difficulties. And this is the power grid. And this future great is to produce hydrogen from the water electrolysis by environment-friendly renewable energy methods, forecasted to be cheaper than industrial production because main input cost is electricity from renewable energy. Solar wind, the technology of hydrogen production from biomass, algae, and biogas is still process of research and testing of the national hydrogen strategy and the budget implementation. With greenhouse emission rising, the frequency of accidents increasing, it is not difficult to see why countries are looking forward to see. Moreover, the global oils and gas is dwarfs of other fuel sources. Forward facing comprehensive energy crisis and need to overcome, and we need the hydrogen seems to be this solution. So thank you very much for listening to me.